Today's demanding laser applications push lasers to the limit of their performance, requiring smaller beam sizes, better mode quality, and stable performance in medical, military, industrial processing, and scientific research and development. The internal components of a laser can change over time, causing the beam to change with a negative impact on your process. Accurate measurement of the laser beam profile enables the user to control the beam, ensuring delivery of the right amount of energy, distributed correctly on the target area for predictable and repeatable results. So the beam you expect is the one you deliver. For medical procedures with consistent, assured outcomes, industrial processes that produce higher quality and reduced scrap, and scientific research results that are accurate and reproducible. Ophir Spiricon is the global leader in precision laser measurement. With over 30 years of product innovation, including Ophir power meters and sensors, and beam profiling from photon scanning slit technology and Spiricon camera-based systems. While a power or energy sensor can measure average or instantaneous laser energy and power output in joules or watts, a beam profiler measures and displays the spatial distribution of the power intensity across the face of a laser beam. Precise measurements of beam characteristics are made with the profiler, including size, shape, expected intensity distribution, and beam divergence. The beam profiler takes all of the physics, science, thermodynamics, and electronics that produces a laser beam and makes precise two-dimensional measurements. Spiricon's beam gauge software presents 2- and 3-dimensional real-time images of the beam that are visually easy to understand. Historical methods of measuring a laser beam include burn papers, wall projections, fluorescent surfaces, and acrylic mode burns. These qualitative methods are not real-time and do not provide enough information about laser performance to be useful. Electromechanical methods to profile your beam include knife edge, spinning wire, camera-based, and scanning slit instruments. The recently acquired Photon family of products includes scanning slit technology, capable of measuring beam size and position to submicron resolution. Photon scanning slit profilers provide a simple method that works well for both CW and multi-kilohertz and above pulsed beams. The profiler is placed in line with the laser beam and measures focused beams with little or no beam attenuation. Spiricon beam profiling systems use a camera sensor to see the entire beam up to 100 times per second. Spiricon's camera-based beam profilers are placed in line with the laser beam. A sample of the beam is split off, attenuated with filters, and directed onto the sensor. The spatial intensity distribution is read from the camera, and the image is displayed and analyzed by Spiricon's beam gauge software. This YAG laser beam was used to mark medical devices. The Spiricon beam profiling system displayed a deformed two-peak beam, causing unreadable serial numbers. Adjusting the laser restored the beam to a Gaussian profile, properly focusing power and restoring quality to the process. This industrial 2 kilowatt CO2 laser beam produced poor welding joints. The Spiricon Pyrocam 3 beam profiler showed a highly asymmetrical beam. Adjusting cavity mirrors restored the beam in less than 10 minutes, eliminating downtime, scrap, and reducing cost per part. This laser joins thin foils for data storage systems. The Spiricon LBS 300 focused spot accessory showed a Gaussian beam profile. Using the correct optics changed the beam from Gaussian to a flat top profile, drastically reducing the rejection rate. One of the advantages of the scanning slit technique used in the photon nanoscan is that the slit plane is the measurement plane, and it is well characterized. This, coupled with the ability to measure most beams directly with additional attenuation optics, makes it possible to find the position of a beam's focus to plus or minus 70 microns. The high precision of the beam measurement helps to ensure the actual waist position is found. From soft X-ray to terahertz, nanowatts to kilowatts, less than a micron to 3 meters. Photon and Spiricon beam profiling systems ensure success of every laser application, whether medical, military, industrial, or scientific. Call 866-755-5499 to discuss your laser application with a sales engineer. Or visit us on the web at ophiropt.com/photonics. Ophir Spiricon Photon, the true measure of laser performance.